So you ready to start the quiz?
Yes.
Let me get in there. Oh, I don't know if I need my VMware. Say no. Oh, yes, we do. I'm going to open that really quick because that just takes a minute. Sorry, I should have had it open.
No, I didn't open mine as well, so it's I guess I always just expect to be lucky and not have to use it.
Right. That's always nice when we don't have to use it.
Mm-hmm.
Sorry, mine's kind of going slow.
That's okay. Mine's really slow too. Yeah, it's like loading right now.
Yeah. So slow. There it goes.
So we're using math self-efficacy and didn't we use math last week?
We used that one a lot.
Okay, I was like,
we're using that one again, is that what you said?
yeah.
Oh, how funny. Yeah, I'm still logging in, so I hadn't looked at it yet. I just saw that there were ones listed there.
Yeah.
But yeah, we use that one a lot. Oh my gosh, I can't believe this semester's almost over. I'm so ready. Okay.
It's just done with math.
Okay, so 1 and 2 are true. So 3, the true linear regression equation y equals bo plus b1, where b null and b1 are unknown. What are the null and alternative hypotheses for b1? So the way that I understand it, I think it's the third one where the null is b1 equals 0.
So equals to
another stuff. And then the alternative would be b1 does not equal 0.
Okay, that makes sense.
Because we want to make sure that, or we want to test to see that is what they're, okay. And then number 4, A residual is the difference between B null and V1 depends on the independent variable, is the difference between the observed value Y and the value predicted by the regression line is left over. Now a residual is, and I have it here. Is the observed value of y and the value that would have been predicted by the regression line. So it's that third one. Difference. Okay, a plot of residual supports using linear regression when the residuals look normally distributed. The residuals are all positive.
So it would be the look normal, right?
Yeah, I think that's the one, because you don't want a pattern and you don't want a megaphone. I don't remember anything about positive, so yeah, I'm going to say that first one too. Normally distributed.
Okay, cool.
Okay, and 6. For the next 8 problems, use the data found in math self-efficacy. Use the confidence variable as the explanatory variable and the score as the response. So confidence, explanatory, and score as the response. Okay. Compute the residual for the data using software. What statement best describes the residuals? Residuals form a linear pattern. The residuals. Okay. And we'll also need QQ plots. And then
Oh crap, what am I doing?
scatter plot. Okay, so that one's math self-efficacy. Okay. So the Y is the confidence. The X is the score.
I'll back. I gotta grab tissue.
Okay. So to find the residuals, we're going to go to Analyze, Regression, Linear. And the dependent is the Y, I think. So that would be the confidence, and independent being the score. Or do I have that? No, I have that backwards.
Does it tell you that it's not allowed in that section?
What?
It says string variables are not allowed in the list. I
haven't gotten that far, but let me see if mine says something like that.
Okay.
No, I got
What does string
let me see what.
mean? So if I go to variable view, it'll pop up and it says the type is a string, and I think that means I can't remember what it means, but I'm trying to remember. Cancel.
So the dependent So the residuals are between about -40 and 25. The residuals form a linear pattern.
So
Residuals are all negative.
you said the score is dependent?
I think I got that backwards. Let me see. Yes, score is dependent and confidence is the independent.
Okay.
Right?
Yeah, I think so. Why is this?
You can see dialogue.
Okay, it's working. Did you put anything for selection variable or case label?
No.
Okay.
Yeah, just the X and Y.
Okay. Model summary. What are we supposed to be looking for? Residuals.
Regression. Save.
For your residual, what did you get?
I'm not getting very much right now, so I'm trying to figure out what the heck is going on.
Yeah, my numbers are huge. Well, not huge, but they're all in like the hundreds.
Because my minimum residual is like a -38. My maximum is like 23. So
so it would be between -40 and 25.
Yeah, I guess, because I don't know why it would say forms a linear pattern, because I don't think. I mean, I don't know. I mean, I guess we could do the QQ plot next and see.
Yeah.
Um,
Let's see if it has. And check out the pattern.
yeah, or the residual plot, which is scatter dot. Why? Click OK. I mean, on the graph, it looks like a linear. I don't know. This one's just so weird. I mean, my residuals, it's like the minimum is -38 and the maximum is 23.4.
Yeah.
So that is true. I mean, I guess we could say that, and then if we want to go back and, if we go through again or whatever.
Yeah. Did your Q plot kind of like go up a little and then down and then back up?
Let me see.
Because mine looks funny.
Let me see. Q. Let me see.
Oops. I'm not trying to print my
page. They look about normal. They're mostly on the line.
Okay.
So I would say fairly normal.
Yeah, I would say the same thing.
Yeah. Okay. I mean, they're kind of, you know, but none of the answers are like, yes, completely normal.
Yeah, which is good because.
Yeah, because it's not completely normal, but I'd say it's fairly. Okay. And then number 8, use software to create a scatter plot of the data. Given the scatter plot, residual plot, and the QQ plot, which of the 5 assumptions about linear regression are satisfied by this data? So the first is supposed to be a linear relationship, which I think it looks like for the most part. So that would be, and then the second is the error term is normally distributed, which we find on that QQ plot of residuals. So yeah, that's where is that one? So that must be the second one. The residual plot, no megaphone shape. So yeah, and then the X values are measured without error. Cannot be checked directly. And observations are independent.
Are you saying that it's all of them?
I think so. All 5 are supposed to be. That's the requirements, but yeah. Why not? Here's B1, the estimate for the slope. For the slope, 1. Is that the one in the coefficients? 12.695. Where is?
Where do we find that?
Last week.
Yeah, did you say 12.965?
695, yeah?
Yeah, 695. Yes,
Yeah.
Yes, that's what I'm looking at.
Okay, I think that's the one. Okay, now construct the confidence interval for B1, which is our slope. And put it into the lower and the upper. So in that same box, I don't know if you have it in yours, but I have the lower being 10.674.
The upper is the 14.75.
Yes. Okay, good. You do have that one in yours. I sometimes forget to click it, so that's why I don't always have them in mine.
Yeah, I did like 3 of them, so I have like all these. I have to like scroll
Over and over again.
Like
so 10.6. Okay, so based on the evidence using level of significance alpha equals 0.05, regarding the hypothesis test for B1. That's 0.000. So we would
reject because it's less than 0.005.
because the p-value is less than alpha, so the third one, right?
Yeah.
Exponential.
Yes.
Awesome.
This test P1 if you check. What does it mean?
P-value less than
so it would be, so it's not at the line, hold on.
There's sufficient evidence that the slope, no, we want it not at.
Yeah.
There's sufficient evidence to conclude that the slope, so the last one, is that what you picked?
Yeah.
There's sufficient evidence to conclude the slope of the line is not at 0.
Mystery crocodile. Oh,
okay, so 13. Oh, mystery crocodile modified. To set the width of the string. Okay. Okay, head length was used to predict body length. So for this data, which variable is the dependent variable? Head length was used to predict body length. So it's head length, right? Now wait. It's body length.
Yeah, I would say body.
Body, okay. So now we're going to construct a 95% confidence interval for B1. Input your answers for the margin of error. Margin of error, lower bound and upper bound. Okay, so I've got to go analyze. Okay. So we said the dependent is body and the independent is head. And we gotta click 95% confidence. So I get 7.218 for the lower and 8.103 for the upper.
Yeah.
Is that right?
Yes.
And then so we take the upper minus the lower and divide by 2, right, to get our margin of error?
Yes, I believe so.
Okay. 7.218. Accept.
So I got 0.443, rounding up the last one.
Okay. Yep, that's what I got. I got 0.4425, so 0.443, and then I'm guessing 16 and 17 are then the lower and the upper, right?
Yeah.
218, 8.123, lower, upper.
Oh, my SPSS just kicked me out.
Oh no! I'm hoping we're already done with it because I don't know what 18
Just
is.
have the last question, which is
Oh yeah.
the reasoning.
Based on your lower bound and upper bound, the last two problems, what can you say? We're 95% confident that the confidence interval will contain the true value, V1. There's a 95. So it's that first one, right? Because it's always you're 95% confident. Okay. So let's see how we did. Okay.
So we got all of them right, but question 8.
Question 8. So it's not all of them.
No, I'm like, I don't know which ones it is.
Well, see, some of them, the ones we did with the plots we know, the only ones that don't use, that can't be checked directly are the X values measured without error. Wait, the variance of error term is constant. And the observations are independent. So those are the only two. Use the software to give the scatter plot result in which of the 5? Oh, so it probably should be all but all 3 of the top ones because we couldn't tell the bottom 2 by the plots, by the.
Yeah.
I'm sorry, I didn't read that right.
I didn't read it either.
I'm gonna go back in.
Okay.
And do it really quick. True. 4. Normally distributed. 6. 7. It's fairly normal. So, the lower is 10.6. Upper is 14.7. Based on evidence. Project null. Margin of error. All right, that time got them all. Yeah, so it's just those top 3.
Okay.
So, because the bottom 2, like I was saying, there's not, they can't be determined by the graphs. So that's where I messed that part up. Sorry.
That's okay.
Okay. So I'm going to send you what I have for the project so far, and just let me know what you think. And when we meet Thursday for our review, will you be able to meet on Thursday?
Yeah, I should be able to.
Okay. And if you need to meet like a little later or whatever, just let me know and we can.
Yep.
we can work around that. So I know that it being the last week of school, things are kind of crazy.
Yeah, well, that day we have an in-class final, so
Oh,
it shouldn't take long because it's only like 20 questions.
oh,
So
right on.
sounds great. But yeah, so I'll be home like around 4 o'clock, so I'll have like an hour to prepare. Yeah.
All right. Then I'll see